So that's kind of the consensus that's changing from, okay, Venus is a dead world to, hey, there may be active volcanism going on right now.
You're listening to The Cosmic Cast. Hello, and welcome back to another episode of The Cosmic Cast, brought to you from the Earth and Solar System team at the University of Manchester. I'm John Penny-Fisher, and I'm joined by the usual array of co-hosts of Peter McArdle, Marissa Lowe, and Elliot Carter.
Hello.
Hello.
And this week, joining us all the way from Zurich is Anna Gülcher. Welcome.
Hi, thank you.
How's it going?
Thanks for the invite.
Well, it's our pleasure indeed. So you're at ETH in Zurich, which is
exactly
kind of like the main university in Zurich, I guess.
Well, there are two. I guess it depends on who you talk to, but for like the natural sciences, it's the main university.
Cool, absolutely. Well, that sounds pretty good. So we've invited you on today because I guess we were reflecting on the fact that we've had a real lack of Venusian episodes. It's definitely something we're striving to correct here at the Cosmic Cast. And you, of course, have been very active in the Venus community of late.
Yeah, definitely.
So I guess maybe we could start off by exploring, how did you get into Venus? I guess we was just saying before we started recording, it's only really recently that there's been an uptick of interest in Venus. So was it quite difficult to break in, or?
Well, to be fair, so I started into Venus science when I was still a graduate student. Mm-hmm. And that was, I think, even late 2017. So you could, 4 years ago, even longer. And back then, I did not know Venus was going to be such a hot topic. So we have some geodynamic modelers and professors in this department whose classes I enjoyed so much that I asked them, like, do you have a cool project for me? I would really like to work on something with you. And there were several topics that I could choose from. And then one of the topics was tectonics on Venus. And I guess it's sort of luck, and it's just good timing that I then chose that topic. And then only when I really did the work and did more and more research about it, I actually noticed how interesting it is and how relevant the timing was. So right now it's much more popular than a few years ago only. So it's pretty cool time to have worked on it just before.
So you could say you're a trendsetter in that regard.
Yeah, although I do think there like already the ground or the stones for this kind of trend has already been laid quite some while ago. But yeah, I'd like to think that.
Yeah, that's really cool. So you mentioned, I guess, a lot of your research is geodynamic modeling and sort of tectonism and that. Maybe be quite, because I'm not too familiar with what geodynamic modeling really means, I guess.
Yeah, geodynamic modeling is really being in the middle between a lot of different scientific fields and trying to bridge all of different hypotheses that come from different fields. So basically what we do is we use computer models to mimic the dynamics of planetary interiors. It could be really on the crustal scale, something very detailed happening just below the surface, or you could run your computer model for the whole planetary mantle, for example. And you're trying, well, it depends really on which questions you want to ask, but you're trying to mimic processes that happen right now or have happened on a planet, and then integrate that with different data from a lot of different fields. So you're definitely not an expert in all of those other fields, but you're trying to talk to as many people.
Yeah.
Because I guess geologists and geochemists and cosmochemists, they all usually do really cool work and end with some sort of hypothesis of how those measurements came about. And then we're trying to test it with computer models or test different hypotheses if it's like physics-wise feasible.
Yeah, that's really cool. So that's really sort of big picture stuff, I guess, as a result of doing this. That's awesome. Yeah.
So how did that lead you to Venus then, this kind of approach?
So yeah, it's easiest to do this with processes that happen on Earth because we have more data, but the exact same questions you can ask for other planets, right? You have the same physical laws that, like, you have just mathematical and physical laws that describes the world as we know it. But every planet has a set of different parameters, and your models like follow the physics. So I think it's quite a hot topic to do it on a few other planets. Like Venus is not the only one. It's just that the comparison with data gets can be much more advanced on, like, if you work on the Earth. So it depends a bit on what you like more. If you want a bit the big picture on Venus, I think we'll come to it later. We definitely have a big problem with good data. But the questions that you ask are maybe even more like relevant or groundbreaking, perhaps.
Yeah, I guess it's the really important data, as you said. Like, there's such a lack of sort of data in terms of what's going on in the ground currently in Venus. I suppose models like these are probably one of the only ways you can really explore what geology might look like on Venus, I suppose.
Yeah, I think, I mean, you cannot have just numerical modeling studies. It definitely has to be integrated with other studies. But for now, like, we know that in the next, 8, 9, 10 years, we will surely not have any new geological data, at least as I'm aware, of the planet. And to try to get as prepared as possible to like the state for new missions, I think numerical modeling is one of the key scientific ways to really try to understand, like, okay, how are these processes working? What if I would find these and these type of rocks at the surface, it may affect, like dynamics or the strength of the rock. You could already beforehand try to know what different potential observations would actually mean in terms of what's going on beneath. I mean, I'm not saying numerical models are always right, but you can get a sense of the physics that is behind it. And if you really get an understanding of certain parameters that represent real observations, you may know more about it. So I think definitely numerical modeling is one of the ways to go forward now without much data, but also maybe reanalyzing older data with new methods, and develop those methods is also a really important aspect.
Yeah.
In terms of the, oh, sorry, go ahead, Marissa.
Oh, okay, thank you. So yeah, I do a lot of numerical modeling for my PhD, but for the moon. So I understand the struggle of trying to like consolidate loads of ideas into one thing. So yeah, what are the main sources of data that you do actually have and that you use in your models? So for Venus,
well, the biggest parameter, like the most simple parameters, we sort of know that we kind of have an estimate for the size of the mantle, its bulk composition. So roughly said, the bulk composition of the Venus is really similar to that of Earth. Of course, it doesn't say much about the distribution of different compositions, but the easy assumption is then that it's kind of has an Earth-like composition. And so you have the big picture. The gravity is a little bit different than that on Earth, but quite similar. And you have the moment of inertia, which also says, again, like you have about a similar size of the core, about a similar size of the mantle. And then we have some samples, like already decades ago, there were some sample measurements which really indicated that the rocks that were sampled were similar to basaltic rocks, like oceanic crust we have here on Earth. And the surface temperature is quite certain. And then there are a lot of, you have to really kind of choose the papers that you trust based on the lithospheric thickness or the crustal thickness. That's definitely not considered certain at all. And it could also very well be that the composition of the crust varies laterally. But so far, the samples that we have measured really in situ were basaltic, but that I think was, of course, not a good coverage. So we go with the data we have and we use it because it's easier to assume it's kind of extrapolating for the whole planet than to make up things. But I'm pretty sure most of these simple views will be proven wrong in the next decade or two.
So I used to work in the oil industry, and we made lots of models of reservoirs and how they behave. And we had a saying about reservoir models, which was models are always wrong, but they're sometimes useful. And I think that's probably what we're saying here as well.
Yeah.
With a lack of data, the models are incredibly useful to think about how things fit together and what test out different scenarios.
Definitely. Yeah. So I really had, when I started working on this project, I mean, I was still a graduate student, just learning to like how to do all the numerical modeling techniques, you know, not a lot of research experience. And I think what a colleague of mine told me, and now I keep thinking about that sentence, is like, oh, so cool that you're studying Venus. Like you have to open your mind and be more creative than you can imagine, because things on Venus don't happen the same way as on Earth. And like just be open for a lot of different interpretations of things. And I think especially in terms of numerical modeling, yeah, that helps there to really not try to have already a predefined view on, oh, I know already how it's going because I've learned it this way. I mean, I guess with maybe some processes on Earth, we have quite a good understanding. So if your data shows something, or you know, your model shows something you didn't expect, you assume is wrong. And yeah, I don't know, that sentence of be really, like you can really be very open-minded with respect to another planet got me really excited. And I still think that's true, even though it also holds for the Earth. But yeah, for a different planet, yeah, we really don't know how things are happening over there.
Yeah, it's that element of the unknown, isn't it? I think it's so appealing. I suppose it's just that mystery of what's going. I think what's quite fascinating is that you know, a lot of the sort of the radar data, I suppose, that we have from the 1970s and all the Russian stuff. I guess it's a snapshot of what Venus was like then. I guess we have no idea what it's like today. And I guess this is part of what you're investigating, isn't it? Could things still be moving about? Are there tectonics? Is there still volcanism? Yeah. And I just find that absolutely fascinating that we've no idea what's going on the surface of Venus today.
Yeah, well, I must admit that we have some pictures and measurements from like the 70s. Indeed, the Soviet Union did a lot of missions at first. I don't expect it has much changed in the last 50 years. We do think the tectonic processes happen a lot slower than on Earth. So, but it would be super exciting to see a new lava flow even, because like volcanism happens, of course, like active lava flows happen over several years, of tens of years. But I think even the bigger question is how, like, we know how Venus looks like now, but what has happened until this time? I mean, that's the question for every planet, also for the Earth, but what has happened that Venus resulted in such a crazy planet with this massive acidic clouds covering like a super hot surface, even though from looking from very far away, if you just know its size and its composition on average, you would say, hey, that's an Earth, like that's an Earth planet. Yeah, that's really
what's
cool.
The current theory for, is there a current leading theory for why that's the case, or is it just completely up in the air?
So I think this answer will change depending on who you ask. Although, like one of the more accepted theories, what I think at least, that generally that's well accepted, is that Venus represents like a sort of mirror of the early Earth. And that something happened that made Earth evolve towards this habitable planet, but that Venus somehow developed this runaway greenhouse effect that made the planet hotter and hotter and more hellish over time. I'm not saying this is the only theory. There are some other theories that even say Venus had oceans. But I think generally we actually think that the Earth developed away from a Venus-like planet and somehow Venus got more stuck. Yeah, I think this is a bit what is out there, but we are realizing more and more that this may not be true. So this is one of the main questions.
This might be a stupid question, but does Venus have like more CO2 or more sulfur than Earth, or is it just distributed differently, or do we have no idea?
Oh, its atmosphere is completely different, I think. So I'm not.
I suppose I mean, but on Earth, do we have the same amount of total stuff, but it's in the mantle, it's in the oceans, and it's in the sediments?
I like that. This I'm not 100% sure of. If you would if the bulk composition also includes the atmosphere composition, but I think on average, yes. We generally think Earth and Venus really started off with very, very similar, if not the same conditions. But yeah, that's, like in detail, I don't know that. But yeah, I think generally we think on average, the two planets should have really similar, percentages of every composition.
So what are the different theories, or perhaps based on the modeling that you've done, what are the different ideas on how volcanism on Venus compares to the Earth? Are there, similarities, say, similar like plume structures, or like ideas of how volcanic eruptions occur?
So indeed, this was one of the topics, or like a sort of general theme of my work. So first of all, in terms of observations of volcanic structures, we see a lot of them on Venus. So I have this picture behind me. You see some also tectonic structures, although what is really kind of the key thing, at least for my field of sciences, is for Venus, there are no mobile plates like on the Earth. So you do not have these ridges where new crust is created and other places where crust is destroyed in this really mosaic pattern. So yeah, the processes are still quite different, but there are a lot of volcanoes and volcanic features detected on Venus. We have a lot of like volcanoes that actually look just like Earth volcanoes, like the caldera volcanoes or shield volcanoes. And people do think that these volcanoes happen kind of in the same style as they do on Earth. There is a magma chamber underneath, and under certain conditions, there are eruptions. And then my work focused actually on the volcanic features that look a bit weirder or more unique than the normal volcano structures that we know. The structures I looked at are massive circular structures that are hundreds of kilometers wide, that have this faulting pattern in a circular structure and have a lot of volcanism around this region. But there's not really one type of morphology that describes these structures. These are massive regions with lots of volcanism and tectonism, and they happen in a circular place. So this has been interpreted to be kind of resulting from deeper mantle upwellings underneath, because they can give rise to these massive circular features and potentially also give rise to volcanic activity in the middle or on the sides. But I've looked at these massive corona structures, and corona is a word for crown. So it's not the virus, it's really like a sort of crown structure. And very long, people have thought that volcanoes on Venus are dead, and tectonics is dead. Like it really looked like these structures are all kind of fossil structures. And then my work kind of showed that there are some features related to these massive corona structures that could hint towards actually active mental activity underneath and interaction with hot magmas rising up from beneath with the crust. So I kind of tried to identify which surface characteristics link to activity and which surface characteristic link to inactivity. And then it actually, like the results were a bit surprising, that we could really tell inactive from active features based on surface topography with the assumptions that we've made in our study. So I think my work and the work of a lot of other scientists in the recent years are showing, hey, the structures that we find on Venus, they're not so passive after all. There might be something really interesting going on there right now. So that's kind of the consensus that's changing in the last, I think, about 10 years. From, okay, Venus is a dead world to, hey, there may be active volcanism going on right now.
Very cool.
It's really cool.
I mean, must admit, there are a lot of assumptions behind it. But yeah, we have to go there and find out if those assumptions are feasible or not.
What is it about, say, the Venusian crust or the mantle that means that if it does have tectonics, they're expressed so differently from on Earth?
So why there is not like a plate tectonics like we see on Earth, right?
Yeah.
Even though it does have
why
tectonics.
do we have these corona structures, say, like we don't have them on Earth? So what's...
Well, the thought is like there may be hints that they happen on Earth or have happened on Earth early on. But the problem with Earth is that we have plate tectonics and the surface is really actively changing over geological time. So features that have happened maybe, let's say, 1 billion years ago are barely preserved on the Earth, while features that are happening on Venus, because there's not that much movement, they stay there. And even though I was just saying some features might be active today, many also may not be active today. And you preserve those signatures much easily on a planet that is not actively resurfacing as much as the Earth.
Because I guess this sort of really links actually quite fundamentally to the question of how did subduction start on Earth in the first place? And I guess that is still quite an unanswered question, isn't it? Because when we talk about tectonics in the context of Venus, am I right in thinking then what we're really talking about is just kind of like different sort of blocks just shuffling around as you might see in like a sort of a big ice pack or something like that? Yeah,
actually, so this is the view that is where the view is currently changing towards. If you probably would have asked this question 30 years ago, everyone would say it's not, nothing is moving, it's all dead, it's all very thick lithosphere without movement, and all the structures you see are very old, or not old, but are happened at a certain time, and since then has nothing happened. But very recently, in the last 10 years or so, there are more and more studies that really show, hey, we think there are regions of activity and then regions of inactivity. And yeah, you can kind of think about the sort of puzzle, or indeed a pack of ice that is not completely broken, but that there are regions where there's more activity and perhaps some resurfacing or local volcanism, and then that activity kind of fades, and then there are other regions patching up. That's how I see it. And more people see it that way. But it used to be really like, okay, Venus has had one episode of resurfacing, and since then, nothing. Yeah.
Didn't the last mission to Venus was the Venus Express mission, right, by ESA?
Yeah, I know of, yeah.
Which
Definitely.
was just like an atmospheric study, I think, and it didn't really look at the surface much. But didn't they tentatively conclude that there was some indications of volcanism as well?
Definitely. So indeed, scientists used data from that mission to try to measure heat emissivity. So sort of heat flow at the surface based on some atmospheric data. And indeed, they actually really revealed regions that are higher than expected heat emissivity. And so that was, I think, in 2015 or so, they already popped up the first papers with, hey, we think these and these and these regions may be sort of hotspots where there currently is something happening. And that has kind of proven to be a really push for other scientists to look again at Venus, I think.
Did those hotspots correspond at all to features like corona or any other volcanic features?
Yeah, so yes and no. So there are several places where a lot of other studies also indicate maybe here there is this broad upwelling mantle because the whole region has this higher than average expected heat flow or something like that, or even gravity to geoid and ratio and all of that. Some of them really seem to be corona correlated, and some of the corona happen really individually. So yeah, so as I said, corona is a name for all these massive circular volcanic tectonic features, but then you can group them into a lot of different types, and whether or not they are related with other structures or completely isolated. So there is not really one way to describe these structures. And my models I run a lot of different type of setups to try to understand the differences between them. And also I could not recreate every single structure or type that is observed. I think there is a lot more to it than what my models have shown so far.
Really great to see multiple lines of evidence pointing towards a similar sort of conclusion that volcanism could be more recent.
Yeah, that is very exciting, that people from completely different fields that I also know nothing about, say, yes, I also found some evidence for current or geologically current activity. So that is really nice. Yeah. That is really exciting.
Yeah, that's really cool. So if money was no object and you could sort of launch any mission you want, is there a particular sort of data set that you feel would be critical to sort of really help advance our understanding of the volcanism or tectonism on Venus?
That's such a PhD Viva question.
That is.
I think they literally asked that in my Viva.
I think I've heard this question a lot of times with Francis defenses. So for me, the problem is not just money, but also technology. Like I said, Venus is quite different than on the Earth. So the conditions are really horrible. Like the atmospheric composition is completely different. It's extremely hot, like 500 degrees Celsius. And the pressure is like you're swimming 100 meters underwater. Like it's 100 times as pressurizing. And I think technology-wise, it's quite difficult. But what would be really cool is to have a lander on the surface of Venus that can measure rock types, that can maybe move around like we're doing at the moment on Mars, right? And even measure some seismic experiments. I think that would be the most exciting, but also really not so feasible in terms of, I think it's more about technology. You're going to invest so much money, and with those extremely hostile conditions, your lander might just die. I think the record is now 1 or 2 hours at the surface.
Yeah, it's not long, is it? Yeah, but basically what we need is more ground truth information, I guess, from Venus. And
I guess that would be most exciting, but in terms of what so there are a few missions coming up in the next decade or two. They are not landers, they are going to orbit around the planet. I am also extremely excited about those ones because they will provide a global coverage of topography, of imagery, of gravity on such a much higher resolution that we have so far. Especially as numerical modelers, then if I compare the computer models with data, I'm limited more by the data of Venus than by my computer models. And in the Earth, it's the other way around, right? Your computer models only can cover a certain scale. And yeah, that may cause some problems or some with comparing with data. And the data we have of Venus is so coarse resolution that even a certain image of a gravity somewhere or a topography somewhere could, in the next set of missions, turn out to be completely different than we thought.
Yeah.
So I'm already excited about it, but a lander, that would be really cool. Yeah.
So one of the big things, apart from a lander, one of the big data sets we're lacking are global compositional maps, aren't they? And I guess that's tied back to the really dense atmosphere. But the new missions will partially address that, won't they?
Yeah, definitely. So we will get, so there is one mission really dedicated to the atmosphere and climate. So I know less about that mission, but they're also going to provide extremely important information. And the other two missions, one by ESA, one by NASA, are a bit complementary in the sense that they will also really focus on indeed a global data set of imagery. I think they will also look at heat flow and what's it called? Like the topography and the gravity, as I said. I think those are really, for geodynamic modelers, the most important. But by radar imagery and by certain measurements of, I'm not sure, like a reflection of the surface, they will also be able to infer a lot about the composition of the rock. It's not my field of science, but they will really look at that. And what is also exciting, I'm not sure which mission, or maybe both, they will circle around the planet for a couple of times over a time span of I don't know, several years at least. So in those few circles, they are really hoping that at least one active lava flow or several active lava flows happen, so that they have one coverage and then another coverage, and they could see somewhere that is looking different than before, or maybe a tectonic episode or so. So I think that would be
cool.
Also be really cool, of course.
Is
So
there any
that
hope
is
of stitching together, or like correctly locating older imagery against the newer imagery, so that you could also see those things, or is it just too difficult?
Yeah, I'm not sure. That would be really cool. But then I think to really say that something has changed compared to the old data set, then the thing that has changed has to be quite big, because the old data set, its resolution is quite big. But there are some regions that we have sharper images of. So if it turns out that exactly there, a volcanic feature looks completely different with different flows, that would be a kind of a coincidence, but that would be possible, but you would need a bit of luck. So I think comparing between the different, I forgot the word, but the different, around the planet, that is more robust than with the old data, but perhaps, yeah.
I remember someone telling me that, I think it must have been the Russians, measured the argon isotope atmosphere, composition of the Venusian atmosphere by essentially strapping a mass spectrometer to a rocket and firing it through. And apparently it's got a 40/36 ratio of 1, which I don't know, if you're a noble gas person, probably, but it's still very strange, right? You've got the same amount of the radiogenic to the non-radiogenic. It's nothing like that on Earth. I don't know. And every time this comes up, I think, it's got a strange atmosphere.
It has. I'm not an atmospheric person, but I think Venus is also one of the most exciting topics right now in atmospheric sciences, or because, what happens there is really different than on Earth. And there was even this paper 2 years ago also, just following mine, about like the potential of life within the atmosphere, which is a bit out there, but it does highlight how different it is there and how much we don't know.
Creative thinking again, right?
Yeah.
Do you have an opinion? Is that the phosgene gas and all that?
Yeah.
In the news,
Yeah.
What's your opinion of that?
I don't have a strong opinion on it because I don't fully understand the science. What I believe, you should definitely talk to people more into it. But what I believe is that they found they measured some things in the atmosphere that could not be explained by the processes that we know are happening there. So I think in the outlook, they described something like maybe there is a type of chemical volcanism that we do not understand that changes some sort of chemistry in the atmosphere, causing these measurements and values that we find in terms of phosphine, I guess. Or it could be a type of micro life that we also do not know about. So I think it's one of the possibilities, but there's something weird happening with the chemistry. For me, I think I would say, I can imagine there is some weird chemistry happening with volcanic outgassing, just because compositions are so different there and here. But I'm not a chemist or a biologist, so I don't fully disagree with the potential of some form of life happening there. but I think the headline of Life on Venus may be a bit exaggerated, like the media does.
Well, yes.
But it helped in turning all the heads to Venus. So
Indeed.
it was right like a year before, like my paper and that paper and some other work that was kind of a bit highlighted in the planetary sciences world was just a year before ESA and NASA selected the missions. So it was really good timing to have a few papers that were actually a bit out there. Yeah.
Well, talking of media stuff, I guess this is an excellent segue then maybe to chat about some of the blogging and some of the writing that you do. Yeah,
sure.
So I guess, how did you get into sort of blogging and writing in the first place? A good place to start, maybe.
So, I mean, I've always been kind of interested in doing something else than studying while I was studying. And when I also started my PhD, I knew I wanted to do something like a side project or something else than my research, because I really like doing research, but I need some hours a week or even more to do something related to it, but very different, and where I can learn a little bit about. So I just met people that were into scientific outreach and blog writing about various scientific topics. And I reached out to them like, hey, can I be involved? How can I be involved? What is needed? And this is in the European Geosciences Union. So this was a conference I went to here in Europe. And I kind of reached out, and it turned out that they really wanted some people joining their team. So I then joined like a blog team for the Geodynamics division. And yeah, I was just happy to kind of be involved and be involved in something else than just my PhD research.
Yeah, that's really cool. I guess, do you write about all sorts of different subject areas, I guess?
So basically, I started out as an editor there with a group of other editors, and we have this really great editor-in-chief, Iris van Zelst. She already set up a really cool structure for the blog, that we have this weekly blog post on the Geodynamics website. So we were all responsible in sequence for a certain week, and we could write blog posts ourselves, but we can also ask, like we usually ask guest authors to write blog posts about topics that they like. And we edit them and we kind of work with them on their blog. And that was really cool because the blogs really vary. So we have a series which is called Peculiar Planets, and then there are Venus and Earth and Mars and a lot of other planets being highlighted. But we also have Geodynamics 1-on-1. So we ask people from a certain expertise to write like a lay summary on what certain methods they use or a certain region. So it can really be anything. And I was in touch with a lot of scientists from all over the world, and I learned a bit about their work, but I also learned more and more about what type of writing works well. So that was really good. So I wrote a few myself, but most of them I edited. Yeah, I think my favorite one is the one I wrote about Venus. For the Peculiar Planet series. But there is a lot of, we also sometimes highlight some challenges that people in academia face, or some tips and tricks. We have this series called the PhD Chronicles, that people just share their struggles and their successes.
Well, yeah, I mean, I think these are really important topics to communicate, and I think quite often the challenges and all that kind of stuff aren't really talked about very often, are they? And so I think it's really critical to highlight problems and struggles.
And for me, at first, some of the blog posts were really, for me, a starting point from looking other relevant information. For example, there was a blog post about organizing your first session in a conference, or writing your first paper, or reviewing your first paper. So I kind of, it was also a starting point for me to look for some really helpful really helpful material. But yeah, it's also fun, like you clean up your writing quite a bit. because multiple people have to look at it and have to edit it. But you can be as serious as you want or not to a certain degree, and that's pretty cool. Yeah,
that's excellent. Well, we'll pop a link in the episode description then if anyone in the audience wants to.
Yeah, that would be good. And we're always open for people to write a feature, or you can also highlight your own work. So I don't know. I like to be part of it, something else than just the science. So that's really, really nice. I think you might have the same feeling about what you're doing here. So
for sure.
Yeah.
Well, listen, Anna, thank you very much for joining us. It's been a real pleasure. Oh no, actually, before we wrap up, we've got one last question that we always ask our guests.
Oh my gosh,
I nearly forgot.
Such a professional.
Not too. Oh my gosh.
Blimey, it's been a while since we put
Oh,
an
dear.
episode.
Okay, I'm very curious now.
So our final question that we ask all our guests is, if you were to start all over again and you didn't pursue academia, is there some other sort of career path or interest you think you might have pursued?
Really good question. I honestly do not know. I would probably be involved in some sort of organization or project management, but because I love organizing everything I can. But
enough,
what of, I really don't know. Like, everything is open. Maybe I would even just be or a teacher. I honestly think teaching is also quite interesting. So
yeah, for sure. Well, certainly.
But my path has just led me sort of here by, like, I just found something I liked, and I found another thing I liked, and it continued like this. I guess early on, if I would pursue something else I liked, I would have maybe ended up completely somewhere else. But where, I do not know. I have a bit too many interests and not one clear vision.
Well, that's never a bad thing, I don't think. Yeah, definitely. It's always good to chase what you enjoy, isn't it?
Yeah. Good question.
Can't believe you forgot.
Caught me off guard.
Anyway, so we had better wrap up now. But Anna, thank you very much for joining us.
Thanks for the invite. That was really
our
lovely.
pleasure. Again, there'll be links in to all your work, some papers, and some summaries in the episode description. To all you lot in the audience, of course, you can continue to follow us on all the various social media feeds. All the links will be on the screen right now. But all that remains for us to say is, Anna, thanks once again, and we'll see you all again very soon for another episode of the Cosmic Cast.
Thanks.
Bye, everyone.
Bye.
Bye.